In this video, I'm going to show you how to conduct Wilcoxon rank test and Kruskal-Wallis test in JMP. The Wilcoxon rank sum test is used whenever we want to compare two population, the median of the two population. To conduct the test, I have taken one dummy data here and make sure that the y variable is continuous and your x variable in this case should be nominal. Now go to analyze, choose fit y by x since data is my y variable and label is the x variable or the factor here. Now the factor here is at the two levels, in aisle and front. So basically this is the comparison of the two population which are in aisle and front. Now click on OK. You will get this output here. Now go to this inverted right triangle, non-parametric, and choose this option Wilcoxon / Kruskal-Wallis test. If there are only two populations under the consideration, JMP will perform Wilcoxon test only, and it will perform two types of Wilcoxon test. One is the normal approximation, and one is based on the normal approximation, and one is based on the chi-square approximation. You can have a look at the p-value here in the case of the normal approximation and here in the case of the chi-square approximation. And if the p-value is low, the null must go through the null hypothesis here is that the median of both the median of both the population is equal, whereas the alternate hypothesis is that they are not equal, significant difference exists between them. Based on these rules, we can actually look at, let's say, the p-value here, and we can conclude that median of both the population is different, significantly different from each other. Now this is how we conduct a Wilcoxon test in JMP whenever we are comparing two population. Now we can extend this idea to conduct the Kruskal-Wallis test, which we use whenever we are interested in comparing three or more than three population medians. For that, I'm taking this particular data set in which I want to compare whether this y variable, which basically represents the sale, is same or different across the in aisle, front, kiosk or expert. So basically there is one factor which is at 4 levels, and this is the y variable. Traditionally we will do one-way ANOVA. However, let's say if we are interested in comparing the median, or let's say the parametric test assumptions are not satisfied, we can go ahead with the Kruskal-Wallis test. To do so, again go to analyze, fit y by x, then put label into the x or factor, put your response variable, in this case this is the data here, and click OK. Now click on this inverted right triangle and now go to non-parametric and choose the same option again. Now instead of Wilcoxon test, basically it is going to perform the Kruskal-Wallis test because we are comparing 4 populations, and this is the chi-square test statistic and this is the corresponding p-value, and as the p-value is less than alpha, so we can say that at least one of the median is significantly different from others. Now to find out which of the medians is significantly different from other, we can click on this inverted right triangle again, go to non-parametric, choose non-parametric multiple comparison and Wilcoxon each pair. The similar process is followed for one-way ANOVA, however we choose different options there. Now here the JMP also gives you the connecting letters report similar to the ANOVA's multiple comparison. Now since the letters are not connected by the same the levels are not connected by the same letter, that means each one of them has significantly different median, highest being for the expert because this is at the top and lowest being for the kiosk. So this is how you conduct the Wilcoxon rank sum test for the two population and Kruskal-Wallis test for comparing 3 or more than 3